Buenos días, React Alicante. My name is ERIK RASMUSSEN, and today I'd like to talk to you about using state machines and how to use them to build amazing UI. So, first of all, what is a state machine? So, I dare not ask how many of you are old enough to remember this device, but it's a pretty good representation of a state machine. When it is stopped, you can press play, and then you're playing, and when you're playing, you can press stop and go back to being stopped. And whenever you're in the stopped state, hitting the stop button doesn't do anything, only hitting the play button does. And when you're in playing, you can hit the play button as much as you want, and you're still going to be in that same state. And notice there's a finite number of states. There's not an infinite number of states, which is why they are sometimes referred to as finite state machines. So before I get into some coding, I'd like to go over some state machine terminology. So a state is one of many finite states that a machine can be in. This is represented by a box on the state chart, and this is not analogous to React useState. It's just representing a state that you're in. It's not a box that you can put values in. A transition is a predefined way to move from one state to another. This is represented by an arrow on the state chart. An event is a value that you give to a state machine that may or may not trigger a transition, like hitting the play button. A guard is a predicate to evaluate if a transition is currently possible. And an action is a side effect that can be fired when a transition occurs or when you enter or exit a state. And one of the most common side effects is to update a value in the state machine's context. Context is a store of data inside the state machine, and this is analogous to React useState or useReducer or Redux. An actor is any entity with which the state machine can interact, often asynchronously, like it can be a callback function or an async function that returns a promise. It can be some observable that sends you lots of events, or it could be other state machines. So the UI that I'm going to attempt to implement today is a fairly common thing that you will recognize. It's an autocomplete search box. And our requirements are that it needs to search as you type. It needs to show a spinner while you're searching so that the user knows that something is going on. And you need to be able to navigate with the keyboard and select with the keyboard, as well as select with the mouse. So I'm going to be using a library called xstate. It is the best way to build state machines in JavaScript by far. And the way that we build a state machine in xstate is like this. And also I'm using TypeScript because I'm a professional. Very good. So what we do is we define our context and our event types. And then we give those types to this setup function that xstate gives us. And that gives us a way to call create machine, where we give it our machine definition in JSON. Now, the cool part about state machines is that rather than have to build out all your state machine definition in JSON with code, you can do it visually. So there's an extension to VS Code that gives you this infinite canvas where you can modify and build your state machine. So if I click to add a new state, I can create a new state, and notice on the left, it's writing the code for me as I am adding states and events. So I can add an event from our no results state for when our query changes, and that goes to searching, and then from searching, we get something back, we get our found results, and once we have results, then we can be selecting, and once we've made a selection, we do select, and rather than go to another state here, we can go back to no results because we don't need to show the results to select anymore. So here we have total control to drag these guys around and make our state machine look as beautiful as we can, and we get this sort of level of visual control. It's like we're drawing on a whiteboard. So notice over here, TypeScript has gotten unhappy with us because we've introduced new events that we haven't strongly typed. So we can go up here to our event type, and we can create our query change, and that's going to have a payload with it that is the string that we have typed into the search box, and then we can define our found results, and Copilot understands that we also need some payload there, but this is a person object that I have created. And then we finally need our select event. So we will add that. And then we can see that TypeScript is now pleased, and we can continue. So now that we're reasonably satisfied that there's this connection here between our visual editor and our machine definition, we can just build visually. So our query change event, we're going to want a side effect called an action, which we can set up with this panel over here. And we're going to want to save our query to the context, both so that we can then use it for searching, but also to have a controlled input if we so choose. And however, we don't necessarily always want to go into searching when query changes. So what we can do is we can click Add Transition here, and we can specify a guard here that we only want to go into searching if we actually have a query, if the user has typed something. And if we don't, then we can just go back to no results. So this is, you can sort of see how we're visually drawing our logic here. We also want a few more bits of payload here. Hold on, excuse me. So if we, so I've also added a guard on if we found results, and when we're searching, we want to invoke this this actor that's going to go do our asynchronous search for us and give back our results that we have found. But what happens if the query changes when we're searching? Well, we can add a way to listen to the query change when we're in the searching state, but if we think about it, really we want to listen to query change all the time, no matter what state we're in. So what we can do is we can drag this from here, not from no results, but here to make it a global listener. And I've broken this over here, but we can add that back. So now, no matter where we are, we're going to go into searching whenever we have the query change. Okay, so we can hit auto layout here, and it does a pretty good job of making this look nice. So let's look at the flow of our machine. So when we get a query change, we go into searching, and then if we have found results, then we go into selecting, and when we select, we go back to no results. So we've got a couple more actions that we need to add. We need to clear the query when we've selected something, and whenever we have found results and we first show the results, we should highlight the first result so that you can hit enter to choose it. And when we don't have any results, then we should clear the previous results that we had. So we can add a clear results here. Okay, so we're getting close, but we need to deal with this selecting state here. So let's pull that aside. And we need to invoke an actor to listen for keyboard events. So we're going to call that keyboard. And here, this actor is going to send us these keyboard events. So we need to listen for one called, say, highlight next, when you hit the down arrow. And that's going to need an action to increment the index. And then another one that is an event that's called highlight previous. And its subsequent action to decrement our index. And then when we hover over one of the options, we want to just set the highlighted index. So even though that's not a keyboard event, when we're in the selecting state, we need to be able to set the highlighted index. Okay, so now we've modeled when we're in our selecting, we're going to listen for keyboard stuff and get these events, and when we hit enter, we can select, and then we go back to no results. So this looks pretty good. Let's hit auto layout one more time and look at what our machine is doing. Let's take this out of the way there. So we're going to start off in no results. That's what that little arrow there means. And we don't need a transition from results because we have this transition that's global for query change. And if we have a query, we're going to go into searching. And that's going to invoke our search actor. And if we have found results, then we go into selecting. If we don't, then we go back to no results. But if we don't have a query, then we sidestep the whole thing and we just end up in no results. And then when we're in selecting, then we are listening for these events to choose. And then when we select, we are going into no results again. Okay, so sadly we're done with the fun drawing part. And now we have to go and actually write the code to make this work. So I'm going to go back over to the machine definition here, and TypeScript has given us a bunch of red squigglies. So let's fix all of these. So first, we've added a couple new events. So let's go and add those up here. Copilot is doing its best to help. So we have highlight next and highlight previous. And very good, select highlighted index, which has a payload of index. And we have a prettier issue here with that semicolon. There we go. So now we've defined our event types. Now we need to define our context type. So in our context, Copilot, well done. We have a query string and some results and a highlighted index. But also potentially we might have a selection once we have made a selection. So now that we have a strongly typed context, we need to provide the initial context down here in our machine definition. So when our machine boots up, we have that initial context, and that's going to be an empty query string. So our input is controlled and results, and sure, -1 is fine. Okay. So now let's implement our guards. So we have those guards of like, do we have results? Or do we have query? Nice try, Copilot. That's the older syntax. The newer syntax is we ignore the first parameter and then we strongly type some params that we get. So we have a query string and pretty good. Let's trim and check the length and return a Boolean. Very good. So then we have results. And it's figured out the new syntax, and that's actually exactly right. So if we have results length greater than 0, then we have results. Very good. Okay, now let's do our actions. So, whoa, Copilot, very good. Again, that's wrong. So we have this assign action for writing to our context. So query is the key in our context that we want to write to, and we use this very similar format where we ignore the first thing and then we strongly type our params with our query, and that's going to set our query into our context. And that's all strongly typed, because we know query is a string, the TypeScript is checking us there. So in the interest of time, I'm going to do a little copy pasting here, but really all of our actions here, if we look, are assign actions. We're assigning some strongly typed params. For clear results, we're just giving back an empty array, and for selecting the first index, we're giving 0. And the rest are just taking these strongly typed params that our action expects and assigning these to our context. Okay, so how do we call these strongly typed guards and actions? So here we can't just use a string, we need to say type, and then here we give it our params, and we can either use event or context here. And here, I don't need to pluck the thing out of event because our event here is found results, and our found results is an object that has results in it, which happens to match the params that we're looking for here. So I can just give it the whole event, and it will be fine. Same with our action here, our set results. I can say type set results, and then just give it our params that are the whole event. And in my experience, most of these are the same for the rest of them. You're just taking the event or the context, or sometimes both, to get your params to give to your actions. So I'm going to paste a little bit more here, but it is really all exactly the same. So let's implement our actor, our keyboard actor that we're invoking here. So we go up here into our setup, just like where we defined our actions and our guards, and let's add an actor here. And this is going to be a callback actor. And there's this from callback function that xstate gives us, and that's going to give me a send back function that obviously is to send an event back. And Copilot has done a pretty good job here. It's actually pretty much exactly what we want. We want to define a handle key down and switch on the event, and we're going to do some prevent defaults here. But when it's down arrow, we want to send highlight next back to the machine, and otherwise highlight previous if it's up, and select. And then we go here and give our event listener to window on key down, and then we return a function to clean up our event listener. This is very much like useEffect. And what's cool about this is our actor is only invoked when we enter the selecting state, and then as soon as we leave the selecting state, it's cleaned up. So we're only ever listening to the key down on window when we are in the selecting state, which is quite nice. Okay. So, yeah. Why is this not working? Okay, so we've implemented our keyboard actor. Now let's do our search. So our search is going to be also a callback. Hold on. Malfunctioning here. Okay. We're going to, our search is going to be a callback as well, except rather than just get send back, we're going to take some input that is our query, obviously. And what we can do here is first we can handle the easy case where we don't have a query. So we can like synchronously send back a no result. And otherwise, we can call our async API to give it our input query and get back our results and send that back. But notice this is not strongly typed, but we can add some generics parameters here that can strongly type our input. So now if we look, our query is a string and TypeScript is all happy. We're sending back no results or results when we get them from the server. Okay, so we're looking pretty good here. Our machine is just over 200 lines and we've designed it visually. So let's go back and remind ourselves of our diagram here. And there's this functionality here where we can simulate, where we can click on events to send them to this machine and then see the state that we're in, and then we can sort of play with the machine to understand how it works. And so this is very useful if you're looking at a machine that someone else designed, or if you're looking at a machine that you designed a month ago. It's good to be able to sort of play with how the state flows through the machine. Okay, so now it's time to look at how we implement the UI. So obviously we're going to use React because here we are. And the way we do this is with a hook, obviously, a use machine hook that XState gives us at XState React. So we have this machine, and this gives us back a tuple of a snapshot and a send function. And then all we have to do is send events to our machine whenever DOM stuff happens. And this is all strongly typed, so like you can't really mess this up. It makes sure that you give the right types of values. And then we just switch on when our state matches no results, and we have a query, we're going to show no results. When we're searching, that's when we show the spinner. And when we are selecting, that's when we show the list of results. And then we hook up our events for when we mouse over or when we click. And we're just sending events and reading state. So this is, it sort of goes back to the original declarative UI promise of when this is your state, draw this, and we don't have any logic in our JSX. Like when React first came out, everyone was like, why is there HTML in my JavaScript? And now I'm more like, why is there JavaScript in my HTML? Because like when you have to put a whole bunch of inline functions in your JSX, it sucks. So let's take this for a little test drive here. I've printed out the state that we're in down at the bottom. And as we type, we go into searching, and then we can arrow up and down, choose make our selection, and it works pretty well. So we're done. It's a Friday afternoon. We're ready to ship to production, and get a call from our manager, and he's like, the backend team is very upset with you. You're banging on our backend server. You're burning up all our cloud credits. You can't do an API request on every key press. He said you have to add debouncing to this. And I don't know how many of you have implemented debouncing before, but it is not as easy as one might think. You have to like make sure that you cancel the previous promise, and it's a big hassle. So it's Friday afternoon. We want to go home. Let's implement debouncing. So we go back over to our state chart, and come on, Keynote. And we create a debouncing state, and we have a a transition to our searching that is an after transition. So after 500 milliseconds, we're going to go always into searching. And then rather to go into searching when our query changes, we're going to go into debouncing. And we're done. We didn't write a line of code. We just dragged some arrows around. So now when we type in our thing, we're briefly debouncing, and then we go to searching, and when we type some more, and it's just, it just worked. Like we visually thought about how that should be, and it's done. So just for fun, I made an attempt to implement this component in pure React hooks, and it looks something like this. So we've got a bunch of set states, a bunch of use state here for all our different values. And then we have this use effect for when query changes, and we do set state, and then we make our API call, and then when we get it back, we set a bunch of other state, and then we've got a finally thing to set our state some more. And then down here in our event listeners, we have to know what arrow down means, and we have to do a bunch of other set states on our click. And we got a bunch of JavaScript in our HTML, and it's just kind of a big mess. And for the experienced React developers out there, you will look at this use effect and not accept this PR, because this is a total disaster. There's all kinds of race conditions. You can't, like, you might get a result back from the server that doesn't match the latest query it's a big mess. But this is, idiomatic React. So let's go over some pros and cons of using state machines to build UI. So you get to think visually. It's like you're brainstorming with your team, and you're drawing on the whiteboard, and you say, no, don't do it like that. You erase that line. You draw some other stuff, and you get to think through the whole flow of your component. But magically, once you're done on the whiteboard, the logic is already written. And then all you have to do is do the little bits to hook it up to the context and things. And it's really nice to be able to reason about time. So rather than having to hold the whole context in your mind at once, you can think about, okay, when I'm in this state, what are the things that I care about? And you don't worry about anything else. It's like, when I'm in this state, if I get this event, I need to do this or fire this side effect. And if I get this event, then I need to go over to this state. And then you can go think about this state and forget about that one. And now you're in this state. Just you're thinking locally about the logic, which for a component like this, it's not that hard to hold the whole thing in your mind, but you can get some pretty big state machines and logic that would be thousands of lines of code, and it's nice to think locally about that. And it's also easy to communicate with the non-technical team members. I had an experience once where I was running through a state chart with a product guy that's never written a line of code in his life, and he was following along, and at one point he said, no, it shouldn't go over there, it should go over to here. And so I was like, oh yeah, I guess you're right. So I dragged the arrow, and he found a bug in the application just looking at these state charts. So that's pretty cool. And you get to live this dream of the declarative UI, where when you're in this state, you draw this. When you're in that state, you draw this. And your UI doesn't need a lot of logic, which makes your React a lot cleaner. And on the other side, it is a new tool to learn. It does take a little bit of time to get up and running and understand what actions and actors and things are. But like any good learning curve, once you get to the top, the view is quite nice. So quickly before I go, I'd like to mention that I've recently started working at a company called Attio. We're building the best CRM on the market. We're going to take down Salesforce. We just raised $1 billion, and we're currently hiring front-end, back-end, and design engineers, remote first in Europe. So if that sounds like something that you might like to participate in, DM me on Twitter, and we will get in touch. Thank you very much.